Welcome back with the AI version of Dr. Rania Kalsi. In this video, we'll explore some of the most fascinating and revolutionary research papers that have shaped the world of generative AI. These papers aren't just academic readings, they are milestones that taught machines how to imagine, create, and even understand us. Each idea you'll discover here has played a role in revolutionizing generative AI. So get ready. This is where we connect the science, the creativity, and the research breakthroughs that define the future of intelligent machines. Now let's dive into the research papers I've carefully selected for this course. Each one represents a major milestone in the evolution of generative AI, ideas that changed how machines learn to imagine and create. You'll get the chance to choose a paper that excites you most and explore it either on your own or with a small group of up to 3 students. And if you're wondering how to read or present a research paper, don't worry. You'll learn that skill with me along the way, how to read an abstract, interpret figures, and summarize contributions like a true researcher. There are 7 core topics, and for each, I've selected 1 or 2 landmark papers for you to choose from. Get ready to discover the ideas that continue to shape and inspire the future of generative AI. We begin with the paper that started it all, Generative Adversarial Networks. When you open this paper, notice how it introduces 2 neural networks, the generator and the discriminator, locked in a creative duel. The generator learns to produce data, and the discriminator learns to judge it. This elegant setup became the foundation for modern image, music, and even video generation. As you read, focus on Figure 1. That's where you'll see the adversarial loop that changed AI forever. Topic 2's paper predates GN's, but remains a masterpiece. It shows how an autoencoder can compress high-dimensional data into a compact latent representation and then reconstruct it. As you open the PDF, notice how short and precise the science article is, just a few pages, yet its impact is enormous. We'll replicate its core idea using Keras in Google Colab, turning theory into practice. In Topic 3, we start with exploring how AI began to imagine. Kingma and Welling's VE paper introduces probabilistic generation. Instead of copying, the model samples from a learned distribution to create new data. When you scroll through their equations, don't panic, focus on the idea of the latent space and the reparameterization trick, both shown in the figures. The second selected paper for Topics 3 is the DCGN paper that takes GNs and stabilizes them using convolutional layers. Look at their generated images, the faces and bedrooms, all created by a computer for the first time. These papers mark the transition from learning to generate data to learning to create meaning. These are 2 milestone papers introducing VAEs and stable convolutional GNs. In Topic 4, we shift from vision to language, and we meet the paper that revolutionized both. Attention is all you need. When you open the PDF, pause at the colorful Figure 1. That's the transformer architecture. It replaces recurrence with attention, allowing models to understand relationships between words no matter how far apart they are. Then we jump to GPT-3, a paper that scaled the transformer to billions of parameters. This paper teaches us about emergent behavior, how models begin to reason, write, and even code once they reach a certain scale. Together, these papers explain how systems like ChatGPT became possible. Topic 5 celebrates creativity. In a neural algorithm of artistic style, you'll see how neural networks can separate content from style and recombine them to create new art, turning photos into Van Gogh or Picasso paintings. Then we revisit transformers, this time in the visual world, through Vision Transformers, VIT. As you scroll through the figures, notice how images are divided into patches, treated like tokens, and processed using the same attention principles as text. These 2 works connect artistic creativity and computational design. By Topic 6, we reach the most modern generation technique, diffusion models. When you open Ho et al.'s paper, look at the sample figures showing images forming gradually from random noise. This process, diffusion and denoising, is what powers tools like DAL E3 and Stable Diffusion. Alongside it, we'll read Closing the AI Accountability Gap, a key paper on ethics and responsibility in AI. It reminds us that with creative power comes social responsibility. How we deploy these models matters as much as how we design them. Our final topic is about synthesis and future directions. This paper offers a comprehensive overview of diffusion models, the newest generation technique in generative AI for vision tasks. It traces how diffusion-based methods evolved from early probabilistic ideas into the powerful architectures that now drive modern tools like Stable Diffusion and DAL-E3. As you open the paper, take a moment to explore how the authors present the taxonomy of diffusion models, ranging from denoising autoencoders to conditional and latent diffusion frameworks. Notice the comparative tables and visual figures. They summarize performance across multiple benchmarks and show why diffusion models have surpassed GNs in both stability and image quality. This survey connects every concept we've discussed throughout the semester, from autoencoders to variational methods, showing how all these ideas converge into today's most advanced and creative image generators. I've also selected for you another amazing paper, one that looks beyond single modality generation and explores the future of multimodal generative AI. This paper examines how modern models combine text, image, audio, and even video to create unified, context-aware outputs, the same technology powering systems such as GPT for Vision and Sora. As you scroll through the survey, focus on the taxonomy diagrams that illustrate how different modalities interact through shared latent spaces and cross-attention mechanisms. The authors also highlight open challenges, aligning multiple modalities, ensuring factual consistency, and finding the right balance between creativity and ethical responsibility. By understanding these multimodal systems, you'll gain a clear view of where generative AI is heading next, toward a world where models can perceive, reason, and create seamlessly across every form of data. Thank you for joining me on this journey into generative AI. Whether you're here to understand the science behind creativity or to build the next generation of AI models, these papers are your gateway. Watch, read, and reflect, because each idea you explore brings you one step closer to becoming part of this incredible field. And remember, if you're enrolled in AI 502, this research project counts for 20% of your final grade. If you're in AI 402, it's optional but highly recommended, and it will count as extra credit. I can't wait to see how you bring these ideas to life through your own presentations and creativity. Please never hesitate to reach out if you have questions, ideas, or simply want to share your progress.